What I'd like you to see for number 12 is that this a plus bi and this a minus bi represents our complex. They're complex because there's a real number and an imaginary number. They're conjugates because the only difference between this term and this term is the negative sign between them. Not completely unlike radical conjugates. So there's some similarities there. But we're showing that the product of these is a real number. So we're saying that a plus bi times a minus bi is equal to a real number. So what we're going to do is FOIL this. We're going to take a times a, and then we're going to take a times bi and a times bi. And then finally, we're going to finish up by taking bi times bi. All right? So what that's going to look like is a squared, okay? And then when we multiply the green, which is a times negative bi, which gives us negative abi. And then we take the other green one, which is a times positive a times bi, which gives us positive abi. And then finally the yellow one, which is bi times negative bi, so that gives me negative b squared I squared. Do you follow that? Now technically I could also write it bi in parentheses, but I think this is going to make a little bit more sense to you when you see kind of where we're going with all of this. So right here, do you see that these are actually inverses of each other, so they subtract out? So then we have a squared minus b squared I squared. Now what I want you to see or remember is that I squared is equal to negative 1, okay? So what we have now is a squared minus b squared times negative 1, which means we have a squared plus b squared as our final value. And those, as you know, are both real numbers. There are no imaginary components to this number. So you have just proven that the complex conjugates is a real number. It's going to come in handy a little bit later, okay?